Okay. Good afternoon, class.
Good afternoon, sir.
Okay. So this is day 2 of today's training. I believe we all had an awesome time in our first class. So we'll be continuing from where we stopped. In our last class, we talked about the overview of SPSS and Minitab. Then we also learned how to compute. If you have a data, you want to compute a new variable. If you have data, you want to compute a new variable. We learned how to do that using compute. We also learned how to recode into same variable. And we also learned how to recode into different variables. Recode into same variable. Like I told you in the last class, if the data is numeric, you can only recode into same variable, a numeric data. If the data is string, you can only recode into the same variable that is string. So I told you also in the last class that I prefer recode into different variable, because that one you will still have the old one and the new variable that you want. So that was the assignment I gave to you. People, and also the assignment of questionnaire. Those that did the assignment, like someone submitted first, he failed it, and I had to correct him before he got it. So I believe all those that submitted the assignment, they now know how to do all the things I taught in the last class. So today we'll continue from where we stopped. Let me open my SPSS as we start. We're going to continue from where we stopped. So we are going to work with our course outline. We already have a course outline. So from our course outline, we've already treated the first 3 parts. So we'll continue from there. Okay. So if you have any, do you have any questions so far based on the assignments that I gave? If you have any question, you can ask them before we continue. Is there anyone that has a question based on what we learned in the first class? Any question? So no question. We can continue. Is there any area you don't understand? If there's any area you don't understand, you can ask now before we continue. Please, can we all mute? Chukwuka, can you mute yourself? Chukwuka, can you mute yourself? Chukwuka is disturbing us. Okay. So I want to copy the course outline, so we'll see the course outline again. So let's look at the chat box. I'm pasting it now. So this is our chat box. So today we'll continue with descriptive statistics. So let me share my screen now. So we are done with overview of SPSS and Minitab, how to define your variables, recode into same variable, and recode into different variables. So next is descriptive statistics. So let me share my screen now. Okay, so can we all see my screen? Can you all see my screen? Can you all see my screen? If you are, wow.
Yes.
Okay. Yeah, okay. So that I will know that you guys are free. So, like I said, we started with this place. We are done with this. We are done with this. We are done with this. We are also done with this. So now we are in analyze. Now, when we talk about descriptive, no, statistics is divided into two aspects. We have descriptive statistics and we have inferential statistics. So statistics is divided into two, the descriptive part and the inferential part. Now, let me differentiate both. The descriptive part just describes the data. It explains the data. It gives a summary of the data. Majorly description explains the data. So that's what the descriptive statistics they do. So example are the mean, the median, the mode, our charts, histogram, bar charts, pie charts, all those things, they describe the data. Even they give us a pictorial representation of the data, they explain the data. Then I want to talk about inferential statistics. Inferential statistics, we use a sample to make conclusion about the population. So let me explain it now. If you go to the hospital and you want to do a test, you go say, let's say you want to do malaria test. They will not take all your blood because if they do that, you will die. So what they will do is they will collect a sample of your blood. Then they will run tests on that sample. Then the result of that sample they collected will be generalized for all your blood. You know, when they bring the result, they will not say this sample we took has malaria. Rather, they will say you have malaria. And they will make that conclusion based on all the blood in your system. So that's how it is. So that's how it is. Can we unmute ourselves? Can you mute yourself, please? I don't know why I cannot mute him from here. I will kick him out of this class. Chukwuka, please, can you mute yourself? Yes. No. Okay. Correct. Chukwuka, please mute yourself. So let's continue. So I was explaining descriptive inferential. I was explaining inferential statistics. So I said inferential statistics, you take a sample, you run analysis on the sample. You take a sample, run analysis on the sample, and you make conclusion using the sample on everything that has to do with the population. So I'm kicking I just kicked him out of the class. Yes.
Sorry, you're not sharing your screen again. No?
Yes, I know. I'm just explaining. I just kicked that Chukwuka out of the class. So please, when you come in, if you know where you are is noisy, just mute. So let's continue. I know I'm not sharing my screen. So I'm talking about inferential statistics. So let me give another example of inferential statistics. So let's say the VC wants to know the average age of students in Futo. That's what the VC wants to know. The average age of students in Futo. Now the VC cannot, it will be difficult to get all the ages of students in Futo because why? Some students are non-academic students. They don't come to class. You only see them during exam period. Even some students also miss exam. Maybe some also because of good reasons, maybe sickness, diseases, lack of finance. So it's not possible for the VC to get all the students. So what the VC can do is to collect a sample. But one thing is that sample must be a true representation of the population. What I mean is the sample must cover every area of the population. You cannot just focus on fair ladies and forget about the black ladies. In that case, the sample is not a true representation of the population. So you consider everyone. So you take a sample and the VC would do analysis on the sample. Then the conclusion that the VC will arrive, when he wants to report it, he will not report that this conclusion is from just the sample. Rather, he will say this conclusion is about Futo entirely. So that's what we mean by inferential statistics. So differential statistics, they take a sample, they run analysis on the sample, and they make conclusion from the sample on everything that has to do with the population. So that's how it is. So we are going to start with descriptive statistics. Santos, thank you. Please just keep on assisting them. Tell Chukwuka to join back, please. Then let him mute himself. So let me share my screen now as we continue. So I believe you can see my screen now. So we are talking about descriptive statistics. Now, we have 3 ways we can do descriptive statistics in SPSS, 3 ways. And the 3 ways will give you, most times, sometimes they give you similar results. Sometimes they give you a result that are not similar. So we have 3 ways. Sometimes they give you similar results. Sometimes they give you results that are not similar. So the first way is this case summary. That's this first one. We have descriptive and we have explore. So we have 4 ways. So let me take them again. We have case summary. That's on in a report. And we have explore. So it depends on what you want. It depends on what you want. It depends on what you want. So let's start with frequency. Let me open the data. Okay, let me teach you guys something which I didn't explain in our first class. So example, if you have a data from Excel and you want to move it to SPSS, how do you do that? You don't need to do copy and paste. Like the assignment I gave to you, I sent my data first on Excel, but I felt that most of you may not know how to move it from Excel to SPSS. That was why I also sent it in SPSS. But I don't think you need to do copy and paste if you have data in Excel, the data set in Excel. So what you have to do is you go to File, you go to Open, you go to Data. Then you locate where the data is. So my own data is in desktop, is in OCP Analytics, the company organizing this training. The folder is in assignment. No, is in folder. Then look at this now. You change the file type because the file type is Excel. You change it to Excel. Before it was in, say SAV is SPSS. This SPSS file format SAV. But since your data is in Excel, you move it to Excel. Then you see the data. You click it and open, or you double click it. Then look at what we show. You know, in Excel, most times you have sheet 1, sheet 2, sheet 3, sheet 4. So it will ask you which of the sheets do you want to copy the data from? Is it sheet 1 or sheet 2? In this particular data, it's only sheet 1 we have. But maybe if you have an Excel sheet that has multiple sheets, so you select it from here. Even in that particular sheet, if you don't want to copy all the data, you also select the range. But in this case, we want to copy everything in sheet 1. Then it will also ask you a question. Do you want to make the first row the names of the, so that SPSS will see the first row as the names of the variables? That's the question. So you select if the first row should be the names of the variables, which that's what you want. So you click OK. Santos, I've seen your hand.
Chidera is asking you to permit him in.
Okay. Okay, let me go back. I've not seen him here. He has not tried to join. Tell him to try to join. Tell him to try to join. Go back. So this is how it is. Because I selected that the first row should be the names of the variables. So that's why this SN now, SPSS is in it as the name of the variable, and student score as the name of the variable. So I believe now we can easily move data from Excel to SPSS. So this assignment I gave, and many people responded, which I'm so happy that they did. So now I want to open one of the assignment I received. Okay, let me open the one from Oji. Yeah, Santos, what was it?
So what of if the assignment you sent is still in let's say Excel? How are you going to should I say transform it to be that is transforming in SPSS?
That's what I showed now. If you want to move it from Excel to SPSS, you go to File, you go to Open, you go to Data, you then select where it is. But you have to change this place, the files of type, you have to change it to Excel. Then you locate where the data is, the file is, and double click. Do you understand?
Yes, sir.
That's all. So that's how I got this data. So now this is the data we have now. So this is the assignment I gave to you guys, and someone submitted it. This is Oji's assignment is submitted. So now let's go back to our descriptive statistics. So now if you are asked now, after they gave you scores of students and you were asked to get the grade of the student, which you've done, then the next thing they will ask is to know the number of students that got is the number of students that got the number of students that failed the course, number of students that got F. So that's what they will ask you next. So if that's frequency, so you go to analyze, go to descriptive statistics, you go to frequency. Then you will select the variable that you want to get the frequency. Is it XN? Is it student score? Is it grade? Yeah, we're talking about grade. Like I taught you in the last class, you can click and drag, or you can double click. You only double click if you have two dialog boxes. This is a dialog box and this is another dialog box. But if there are three, you cannot do double clicking. You only double click when there are two. So if there are three, you cannot do double clicking. So either click and drag, or you click and use your arrow. So that's all we need. Then if you want to see, if you want a chart to come out with the results, you go to chart and select the chart that you want to come out with the results. Which of the chart you want? So if you want bar chart, you click bar chart. If you want pie chart, you click pie chart. Then also it will ask you, is it frequency or percentage that you want to come with the result? So let's start with frequency, then we can repeat it and go to percentage. Continue. Okay. So look at the result. The first thing is telling you valid 1,000. That means our N for this analysis is 1,000. Missing. Is there anything missing? None missing. So about the number of A's we have here is 424 students got A, 140 students got B, 64 got E, and 153 got F. Now, percentage is this. Then we have valid percentage. Then we have cumulative percentage. So most times what I do is SPSS will give you SS results. SSS will give you different types of results. So you'll be the one to select. Wait, let me send the link. Give me a minute. Let me send the link so that others can join. Santos, please, can you tell Chukwuka to click the link again and join?
Okay, sir.
Tell Lois also to join. So let's continue. So look at this now. Most times, SPSS will give you a result. So you have to select the ones you want. You have to select what. So if you want to select the ones you want, you have to double click the table so that you can edit the table. Are we together? Let me go back. SPSS will give you the result. You have to edit the result to put it the way you want. So to do that, you double click the table. So when you double click it, you have the opportunity to correct this or to arrange it the way you want, not that to correct. It's correct. So most times I may leave this, I may delete this valid percentage. I will highlight and delete. If I don't want cumulative percentage, also I can highlight and delete. The cumulative percentage is just is adding this to this, this to this, this to this. That's what it's doing. That's what the cumulative percentage is doing. So you can highlight and delete if you want it. That if you don't want it. Then once you double click, you have the opportunity to edit it. Once you are done, what you do is to click outside this table. Once you click outside this table, it will tell SPSS that you are done editing it. So if I click here, it means I'm done editing it. The same thing with the chart. You can also edit it. So I can double click it. Once I double click it, it will give me the opportunity to edit it. So it will add, if you want to change the color, if you want to change the color of the bars, you click any of the bar. Once you click any of the bar, you have the opportunity to change the color from here. Are we seeing this place?
So it's dark here. As in, I can't see what you are clicking on.
Can you see this chart?
No,
Can you
sir.
see the bar chart?
Can't see. It's dark. It's dark. As in, can't see it, sir.
Can you see this?
You removed it.
Yes, but can you see this one? Can you see this chart?
Yes, sir.
Okay, let me double click. Can you see this one?
No.
You cannot see.
Yes, sir. I can't see.
Peter, can you see it?
The chart is hidden. What I'm seeing is just a blank black space.
Can you see it now?
Exactly. No.
You cannot see it.
I cannot
Yes,
see
I
any
can't.
chart. I'm just
Okay.
seeing a blank space.
Can you see it now?
Yes,
Yes,
sir.
yes, yes.
Okay. I'm coming soon. A minute. So let me go back. So once you double click the chart, you can see the chart now, right?
Yes.
Once you double click it, this is what will open. So if you want to change the color of the bars, you click any of the bars, you click any of them. Once you click any of them, you come to this place and change the color you want.
Okay.
So you design it. Then if you, now what we know that A is 40, we don't know the exact, if you look at the chart now, you may not know the exact number, but you know it's between 400 and what, 450. So 450 will be around there. B is 500. So you know that is between, but if you want to know the exact number, if you want SPSS to write the number on top of it, you click this. Are we seeing this? So if I click it now, it will write the number. Now, if you want the, are we seeing this? Let me move it. Are we seeing this? If you want to change, if you want this thing to go up, you click this. We click custom. Once you click custom, you now direct it where you want it. If I click here to go up and apply, are we seeing that the number has gone up? If I want it to come down, I will click here and click apply to come down. If I want it to be at the center, I will click here and click apply. I like keeping it at the top most times. Then apart from that, you can also direct it the way you want. You can arrange it the way you want. So you click it. Are you seeing that you click and drag? Are you seeing it?
Yes, sir.
I can click and move it this way. I can click and move it this way. I can click and move it this way. Are we following?
Yeah.
Yes, sir.
So
Can you change the individual, like can you make each bar to be different colors?
if we can make each bar to be different color,
Yes.
let's try that and see. I've not done that before.
Okay.
I've not done that before. I don't think it's possible.
It's not a problem. You can continue.
Okay. So once you are done with this, you cancel this. Once you are done with everything, there's no place to say. Once you cancel, just close it. Once you are done, just close it. It will show you. Can you see this screen now? Can you all see the screen?
Yes, we are seeing the screen.
Okay, okay.
It's showing the chart, sir.
Yes. Have you seen that the chart has changed? It's looking better now. But don't move your numbers this way. The way the numbers are, they are not okay. I was just trying to show you guys something. But the color is fine. The color is okay. But you can then also, if you want to edit all these things, this frequency, if you want to edit even the title, if you want to change the title, you can. Can you see the chart? Can you see this?
Last part, the chart that I showed is still showing with where you can choose the color of the chart to.
No, it's not showing. If you cancel this, it's not showing again. Where is it showing? It's not showing again.
That's what is showing in my own side.
Your network is low.
A chart is showing and plus color where you can change the color of the chart.
Is that what it's showing?
Yes.
Yes, sir.
Okay, let me stop sharing. Okay. Okay, that means people are current. So can you see this now?
Yes.
Yes, sir.
Okay, so this is what I want now. Sizing the chart is okay. Very okay. So we can now continue. So like I was explaining, can you see this one now? I've double clicked it. Can you see this?
Yes.
You can edit this thing here. You can edit we call it the this is the Y the name of the Y axis. So currently it's frequency. You can change it if you want to change it. You change it to anything. So I can put frequency of voice or anything. Frequency of the grade. So you can change it. So people usually come to us to plot graph and we charge them money. We collect money. You may think it's easy. It's easy because you know it. Someone that doesn't know it won't know it is easy. So I can put the grades of the students. So don't allow anybody to come and tell you it's easy. If the thing is easy, the person will do it. So if you don't want title, you can click and delete it. That's if you don't want the title. You can just click and delete it. So I can exit. So are we seeing this now, right? We are seeing this and the table.
Yes.
Okay. So that's it now. So what we've done so far is frequency distribution. Mr. Godwin Oji, you're welcome. Okay, it's not with us. So we've been able to learn frequency. So can we go to the next thing? So now, when do you use frequency? Like this example now, we have grades of students and we want to know the number of A's, the number of B's, numbers of C's, numbers of D's. We want to know the percent of students. We want to know the percent of students with A, the percent of students with B. So let me apply to other real life examples. So let's say you have a data of COVID-19, different people were tested, some positive, some negative. So they want to know the number of people that tested positive and the number of people that tested negative. They can't start counting all of them to know the number that's positive and the number that's negative, since they already have the data on the system. So what you have to do is just to use a frequency distribution table. So it will tell you the number, it will also calculate the percentage for you. You can also show this using a bar chart or a pie chart. So let's try using a pie chart. Let's try using a pie chart. So we'll go to analyze, descriptive, frequency. You just have to change the chart to what? Pie chart, that's all. Please don't use this histogram in SPSS is not correct. That's not what they taught us in histogram. So this is the pie chart. You can, if you want to edit it, you can edit it, you double click it. Are we seeing this?
Yeah.
So you can redo it.
Can I what?
Redo it again.
Okay, you just go to analyze. You go back to your frequency. Then all you have to change is your chart. You click chart. So which chart? Is it the pie chart or bar chart? We've done bar chart, so now we are doing pie chart. You click continue. Then you just click OK to bring out this. Then if you want to edit it, you double click it. If you want to change the color, you click any of this. Let me see this. If you want to change any color, you click this. If I want to change this red, I can click this and change it to. Is it working? Because like I can't change it to the default color. So if you want to add number, if you want to add the number, you click this. The number will show. No. You click this, the number will show. Then to ask you what is showing now is, look at this now. what is showing is only the percentage. That's what it's showing, the percentage. So I can close and close. So this is what we have, the pie chart. We still have our frequency. Then you can edit this and you can delete the valid percentage if you don't want it. For most of the valid and the percentage, they are the same thing. It will only be different if you have missing values. But since we don't have missing values, they will always be the same. So the difference between the percent and valid percent, maybe if you have missing values, that's when the percent and valid percent will be different. So which most times we don't have missing cases. So I always leave the valid percent. So that's all for frequency. Any question? Any question?
No question.
Okay.
No, sir.
Why is Chukwuka not joining us again? Is he having network issues? Okay, so let's continue. So the next thing we're going to learn. Onyedika, are you following us? You can unmute yourself and answer. Are you following us? Onyedika. Okay, so let's continue. So like I told you, for descriptive statistics, we are going to use four different options. We can use the case summaries. We use explore, frequency, and descriptive. Now, but it depends on what you want to get. That's what will determine what you will use. If you want to get the mean, you know what we worked with, the A, B to F. These are what? They are string categorical variables. That's why we use the frequency. You cannot, if you use frequency for the actual scores, it will not be okay. Let me show you what I mean. If you use frequency for the actual score, if you want to everything to return back to normal, you click reset. If you use frequency for the actual score, which are quantitative variables, look at what you will get. This it shows that you are not a statistician and you are not an analyst. You can't give someone a result like this. So that's why most times it's good to code. When you code it to either A, B, C, D, E, F, or maybe an interval, you can now take the frequency. So when you have a quantitative data like this, so what do? You can look for the mean, the median, the mode. That's what you can use to summarize your data and report it. So in that case, we can use descriptive. So you click the student score. If you watch in descriptive takes only quantitative variable. That's why we're using this. So you click descriptive. Descriptive takes only quantitative variable. That's why grade is not showing here. If you watch your grade is not showing here. Why? Because grade, you cannot look for the descriptive of grade. You can only take the frequency of grade. Frequency works for both quantitative and qualitative, but majorly it's used for qualitative. Qualitative means categorical. Categorical means alphabet, characters. So that's what we mean. So now for descriptive, we work with only quantitative. Quantitative means numeric, numbers. So you move it. Because we have two dialog boxes, you can double click it. You can click and drag, or you can click and use your arrow. Then you click your option and select what you want. We already have default. The default here, it means standard deviation, minimum, maximum. So you select what you want. So if you want the sum also, you select. If you want variance, you select. If I want range, I can select range. So you select what you want and click continue. You click OK. So it will give you a summary of the data. So what do we have there? It's telling us that range is 70. Now, one thing about as an analyst, you have to learn how to interpret your results. You know, the definition of statistics, after defining statistics, it must end with the ability to use everything you are doing to make decisions. It has to do with decision making. So looking at this result, now anybody can use SPSS to do whatever they want to do. So the difference between an analyst and the roadside man that is using SPSS is that an analyst can interpret it very well. So looking at this now, the range is 70. So what does it mean? It means that the difference between the highest and the lowest student in that class is 70. It shows that it's very bad. Why will a student be scoring very high and in that same class, another student is scoring low? to the extent that if you subtract the highest student from the lowest student, you will get 70. So it shows that that class, they have very good students, and it also shows that they have very poor students. So the work of every teacher will be to minimize the range so that even though we still have good students, but at least the difference between the highest student and the lowest student should not be so high. The difference between the highest student and the lowest student should not be so high. So that should be the work of every teacher. Then the minimum is 30, telling us that the lowest value is 30. That means the least score the student in that class scored is 30. Maximum is 100, telling us the highest a student scored in that class is 100. Then the mean is telling me the average performance of the all the students in the class. So on an average, all the students in that class is expected to score 64. Then the standard deviation measures the variation. When the standard deviation is high, it means the variation there means how the scores of all the students varies. So if the variation is high, it means that the student, they didn't score they didn't get scores that are close to each other. So let me give an example. If in a class, all the students, they write an exam that is over 100 and they are getting 80, 70, 80, 70, the standard deviation will be very small. What is it trying to tell us is that the scores of all the students are close to each other. But when a student is scoring 10, 20, another one is getting 100, 80, the standard deviation will be very high. So what is it trying to tell us? That the scores, they are very far from each other, that they are not close to each other. So standard deviation measures the variation from the mean. It measures the variation from the mean. So it measures how the values in the data set varies from each other. So the higher the standard deviation, the higher the variation within that data set. So like I said, as a statistician, you must be able to interpret any analysis you do. What separates you from a roadside man using SPSS is the ability to interpret. Most times, people do analysis and they cannot interpret, and they send it to us to assist them. So I've been able to explain when to use frequency and when to use descriptive. In descriptive, we use it for quantitative, numeric data. While for qualitative, we use frequency. So please, any question? Any question? So no question. So we can continue. So the next thing we're going to learn is we are done with Felicity. Can you hear me? Okay, she has gone. Shidera, are you with us? Emmanuel, can you hear me? Okay, so let's continue. So if I go to the next thing we are going to learn is explore. So let me create a new variable here. Let me create a new variable here. I want to create a new variable here. I want to call it gender. Then I want to 0 and 1. I want to use 0 and 1. I want to use 0 and 1.
Sorry, I can't see where you're typing.
Yeah, I don't need to see, no problem.
Okay.
I just, when I finish, I'll move it to there. Okay, let me show you what I'm doing. Can you see what I'm doing now? Can you see what I'm doing?
Yes, yes.
Okay. I'm just trying to create variables, but it will take me time because we have 1,000 data there.
Okay.
It will take me time. Okay. Let me teach you people how to simulate data, how I got that data. So let's learn something else. Let's learn a little of arrow. Can you see my arrow now? Can you see my arrow?
Check your arrow, let's see.
You can't see it. Okay. Let me. Can you see my arrow? My
Yes,
arrow
sir.
programming. Okay. So I want to show you how to simulate data now. So this is not part of what we are learning, but it's also good. So you can, when you go to arrow, so I want to simulate data for 1,000 people. And I want it to be between 0 and 1. 0 and 1 means male and female. So I will use, you will now look for the distribution that will give you 0 and 1. The distribution that will give me 0 and 1 is Bernoulli or binomial. So I can use Bernoulli. So I will use arrow Ben. Or let me use binomial. Arrow binom. It will ask me this. N is what? The size. What's the number of data I want to simulate? Are we seeing this thing that is up? The first thing is N. So I want to simulate 1,000 data. But I want it to be between 0 and 1. That's why I'm using 1. So 1 is the highest value I should get. Then I want to use, you can want it to be equal. You want equal number of 0 and equal number of 1. You can use 0.5, but I don't want it to be equal. So I want 1 to be greater than the other. So I will use 0.35. Let me call it a name. So A is equal to this. Then I will click run. Then if I want to see my data, I can click the name A and click run again. So look at the data I've simulated. So now I want to move it. I want to move it to SPSS, to Excel, CSV first. I will write a code called write.csv. Write.csv. Then I will put the data that I just simulated, which is A, comma. What's the name of the, what do I want to save the file as? Save the file as data for gender. That's the name of the file. So I will run it. Once I run it, it has saved. So I'll go to my document. Are we seeing my screen?
Yes.
I'll go to my document. Then I'll remember what I saved the data as. Data for what?
For gender.
Gender. I don't know why this is not allowing me to use Excel to open it. So I'll open it with Word.
I'll convert yourself.
Then I'll copy it. Then I'll go to Excel. Can we see my Excel?
Yes.
I'll go to Excel and paste it. So even that, then if I want to remove all this, what do they call it? If I want to remove all this quotation mark, I'll go to data. I'll go to test to column. I'll go to next. I'll go to comma. Look at this thing now. I want this comma. I want it to put a line in this comma and separate it. So I'll click comma. Are you seeing it? Are we following?
Yes.
Try to create it. So I want to, are we seeing it? So I've been able to get my 1,000 data. So I can now copy it and go back to my SPSS.
Sure.
Peter say sure. So let me go to my SPSS. Correct. So now I have my data. So remember what I taught you. You know, this is a coded data. So I want to use 0 as, then I'll come back to this. I'll use 0 as what? Male. 0 means male. Y, then I'll click add. Y1 means female. I'll click add, then I'll click OK. I can change it.
All right.
Eh?
Okay, you've done that.
What? What did you say?
Don't worry, don't worry.
Okay, so now it's 0 and 1. If I want to check if what I coded is correct. Chidera is really trying to join us, but he's having issues. If I want to check if what I coded is correct, I will click what? This. That means what I coded is correct. Confirm. So we now have 1,000 data for gender. So can we try to do frequency for this? If I want to do frequency for this, I'll go to what? Analyze, descriptive, frequency. I will reset it first. Then I'll move my gender to this place and click. If I want chart, I go to chart. I want a bar chart. Okay, and okay. So this is it. So we have 666. This is 66 male, and we have 334 females. Then is my bar chart. We can change the color if you want. So let's go back to this now. What we want to learn is how to use. So now, what if I'm interested? The reason why I brought this new column. So two people want to join us. Techno Spark 4 and Chidera. Chidera is really having issues. So back to this. So if I want to look at what I want to do now, I want to look for the mean age, the mean score for males and the mean score for females. In that case, I'm interested in their score, the exam scores, but I want to create two groups. What do I want to use to create the two groups? I want to use what? Gender. So in that case, you cannot use descriptive to do that because descriptive didn't give us opportunity to create two groups. Descriptive didn't give us that. So I can't use descriptive to do that. I can't also use frequency because frequency doesn't work with category numeric data. So I can't use frequency to work with their scores. Like it can work, but it will not give you what you want. So now the two things you can either use is the case summary or you use what? Explore. So let's go to explore. If you go to explore, this dependent is the actual data that you want to work on. What's the data you want to work on? You want to work on student scores. You want to work on student scores. Then this factor list is what you want to use to group them. I want to use the agenda to group them. Then you go to statistics and select what you want. You want the descriptive statistics. Okay. If you want plots or only statistics, but if you want both of them, you leave it at both. I will still go back to this again, but let's see how the result is so that you understand what I mean. So this is what I mean. Lois, you are welcome. So this is what I mean. So I've been able, I have a male 66, female 334. So look at this now. It has been able to split my result to both male and female. So for male, it will give me the mean, it will give me the confidence interval, it will give me the median, it will give me the variance. For all these now, they are for what? Males. All these are for what? Females. So now difference between this and descriptive function, the difference between explore and descriptive function is that the difference between explore and descriptive is that in explore, you have the opportunity to create a group. While in descriptive, you don't have the opportunity to create a group. So in explore, if I have two groups, male and female, I can create two groups and be able to know the mean score for the first group and the mean score for the second group. So now in this case, I can do comparison. So if I want to compare now, I can look at the mean for male and say it's what? 52.42, and the mean for female is what? 87.24. So it means the males who have in this class, they are Olodo. They don't know anything. So the females like Lois, they are very intelligent. That's why they got 87.24. They are very, very intelligent. So now look at the confidence interval. Then let's look at the variance. If you see the variance, okay, let me use standard deviation. Standard deviation for male is 13.2. Standard deviation for male is 13.254. While for female is what? 7.23. It means the males, they are just scoring different from each other. That means their scores are not moving within a particular range. Some are scoring high, while some are scoring low. But for the females, it's like all of them, they read together, they study together, and all their scores are similar. That's why their standard deviation is small. So it means the scores for males, they vary more than the scores for females. So the scores for females, they are up 7.2, while the scores for male is 13.2, the variation 13.254. We'll talk about the range. Range means the difference between the highest and the lowest is 24 for female, while for male is 45. It means that if you watch, that means the difference between the highest students and the lowest student for male is very high compared to female. So that's how it is. So the essence for the reason why we use explore. Explore, if we have two groups, we can use explore to do descriptive statistics on the two groups and be able to do comparison. So that's how it is. So let me go back again and explain what I did. So if you want, so you have a data and you want to look for the mean, the descriptive statistics of this data, the mean, range, standard deviation, variance, and the minimum value, maximum value. But you want to split it using male and female. So you want to know all this for male and all this for female. You go to analyze, you go to descriptive statistic, and you go to explore. Let me reset it. So this is where you put what you are really interested in. I'm interested in what the student scores. You have different ways of moving it. You can click and move it, or you click and use this arrow. So that now in this case you cannot double click. Do you know why we cannot double click? It's because we have we have 4 dialog boxes here, so you cannot double click. So if I double click, it will not go. I'm double clicking now. You see, I'm double clicking, it's not going. Why is it not going? Because we have 4 dialog boxes. It doesn't know where to send it to. So when you have more than 2 dialog boxes, either you click and drag, or you click and use your arrow key. Then this is where you want to create a group. If you want to create a group, what do you want to use to create the group? I can now use what? Gender to create the group. You now go to statistics if you want. Now I want to show you the difference between this explore and case summary. That's my next thing. If you watch where this explore didn't give us the option to select the descriptive statistics we want. It just told us descriptive statistics. It didn't give us the option to select. So look at there, when you click it, it will show you, look at the descriptive statistics that are there. It didn't give us the option to select. Then, like I told you, SPSS will give you results most times that you don't want. So if you discover that there are some things here you do not like, you double click it. So if you double click it, you now start deleting what you don't want. This 5% trim, I don't want it. I will highlight it and delete. I will also do that for female. So if there's any other thing, you may not need interquartile range. You highlight it and delete, and do that for female also. So you arrange the result the way you want. If you may not need skewness and kurtosis, you highlight, delete. You also do that for male. You highlight, delete. So you always arrange your result. Don't just copy results from SPSS and copy everything and paste. No, you use the ones you want. You highlight, delete the ones you don't want. So when you are done editing, you click outside. So if I want to edit this table, what will I do? I will double click it. When I double click it, it will give me the opportunity to edit it. Then when I'm done editing it, I can click outside here. So that's all. The explore gave me different results. It gave me stem and leaf plot, which is this. It gave me box plot, but we are not talking about all this. We'll explain this later. When I start teaching you how to visualize data, how to plot data, so I will explain box plot, but that's not what we are doing. But hope we now know how to use explore. So I want to show you the last one, which is case summary. So you go to case summary. The same thing that explore did. We move the student score here, and we move the gender here. We want to group it. I will untick this. I will explain why I did this. I will explain later. I will come to statistics. If you watch where, are you seeing the difference between explore and case summary? Explore didn't give us the option to select what we want. It just gave us descriptive statistics. And once you click it, everything will come out. Then maybe when the result comes out, you can now edit the table and select the ones you want. But for case summary will give you the opportunity to select now what and what you want. So it will give you the opportunity to select what and what you want. So the ones you don't want will not come out. So I'm done selecting. I can click continue. Okay, so then okay. Are we seeing the difference? So look at how the result is. Look at how the result is in Explore. Look at how the result is in Explore. Now look at how the result is in a case summary. Most times I prefer using case summary. Why do I prefer using case summary? The result is arranged well. I can easily compare them, unlike this. Are we seeing the difference? In this case, I can easily compare them. But both of them are the same thing. Check. N is 66,334. The same thing with this. N is 66,334. The mean here is what? 52 and 87. Mean is what? 52 and 87. So it's your choice. Both of them do the same thing. But the only thing is that in case summary, you cannot see confidence interval. But you can see confidence interval in Explore. But you cannot see it in case summary. In case summary, you cannot see confidence interval. But you can see the rest. We have range. The range here is 24. Are we seeing the range? Range is 24. So both of them they give us the same result. So it depends on what you want. So most times when they give us work, someone can bring a work to us and tell us, I have a work on the student's course, but I want to split it into male and female. Then after splitting it, I want to calculate the mean, the standard deviation, the variance, the range for both males and for both females. Please assist me. Then as an analyst, I will be the one to decide, should I use Explore or should I use Explore, should I use case summary? So anyone I want, if I want Explore, I go to this. If I want case summary, I go to this. Then like I've been saying, the difference between you and a roadside user of SPSS is that you can interpret. So you can, after doing your analysis, you have to interpret your results. So when you are done, you interpret. So you interpret the range. What's range? Range means what? If you want to interpret this now, look at how I will interpret it. I will tell them the difference between the highest male and the lowest male is 45. I've interpreted this. I didn't say it's range. I know that it's range, but I've interpreted it. How did I interpret it? I will tell them that the difference between the highest student for male and the lowest student for male is 45, while the difference between the highest student for female and the lowest student for female is 24. I've interpreted range. Then for maximum, if I want to interpret, I would say the highest score that a male got in this test is 75, while the highest score that a female got is 100. I've interpreted it. Then for mean, I'll say the average performance of all the males is 52.42, while the average performance of all the females is 87.24. Then for N, if I want to interpret N, I would say in this class, we have 666 males against 334 females. Then if I want to interpret the standard deviation, I would say the scores for males varies, or the variation between the scores of males is higher than the variation between the scores of female students. The variation for male is 13.254, while the variation for female is 7.203. And this means that the males, they were not performing similar to each other. They were performing differently. While for females, like most of them perform or got the same score, perform similarly. So that's it. So after doing any analysis, you have to interpret it. So I think we are done with descriptive statistics. Any question?
Sir Paul, I'm not following.